Hello everyone, I welcome you all to this lecture. In this lecture, I am going to discuss another type of encoder, which is octal to binary encoder. So as you all are already aware about, in octal system, we have 8 symbols starting from 0 till 7. So these symbols we are trying to convert. So this is octal system, and in binary we have only 2 symbols, that is 0 and 1. So when we try to generate an encoder from octal to binary, we try to convert these number into binary. So it is also very well known that if there are 8 numbers and we try to convert 8 numbers into binary, so to get 8 different values, we need to have 3-bit representation, right? So that means for this task, for octal to binary conversion, we can have 8 cross 3 encoder. So if I draw like this, it will be looking like 8 cross 3 encoder can act as octal to binary encoder. So let's look at here. There are 8 input lines. So let's say like this, and there are 3 output lines. Okay, so if I number them, let's say I'm saying it is 0, it is 1, it's 2, 3, 4, 5, 6, and 7. Now these output lines I can number like y2, y1, and y0, right? Like this. So if we represent it in terms of a truth table, we can have a truth table like this, where we have, there are different inputs. So let's say we are having 8 inputs. Like this we can draw it. So okay, consider it as like this, and here I'm writing, let's say it is 0, or I can write I0, I1, I2, or you can write 0, 1, 2, 3, 4. You can write in otherwise also, it's not a problem. If you want to represent in otherwise, like first we represent 7, let's say 6, 5, 4, 3, 2, 1, and 0. And there are 3 outputs, so let's say you are having y2, y1, and y0. Now you feel that, let's say initially I assume that this 0 is high. So if this is 1, rest of the places I assume all are 0. This 0 in 3 bits when we represent will give us all 0, right? So if we convert 0, which is given in octal system, In binary also it will be represented as 0. If we want to represent it in 3-bit, then there will be all three will be 0, right? Now next, if I consider this first input, let's say it is high and rest of the inputs are low, so all are having 0. Now because this one input is high, one we can represent in 3-bit like 0 0 1. Similarly, let's say now I consider this second input is high and rest of the inputs are low like this. So this 2 will be converted like 0 1 0. Similarly, if I consider this 3 input is high and rest of the inputs are low like this, then this 3 can be represented like 0 1 1. Okay, now let's say in next row, let's say I assume this I4 is high and rest of the inputs are low like this. In that case, this 4 we can represent as 1 0 0 in 3-bit, right? 1 0 0 will represent 4. Okay, now next time, let's say I'm assuming this fifth input is high and rest of the places are 0 like this. 5 we need to represent in 3-bit and binary, so it will give 1 0 1, will give us 5, right? Now let's say if I assume this input is high and remaining inputs are 0 like this. In that case, when we represent the 6 in binary, it will give us 1 1 0. Similarly, when we get 7 as high and remaining inputs are, let's say, low, then in that case we will get all three 1 as high, right? So now let's find out the Boolean expression for y0, y1 and y2. So I hope it is not very difficult to write the Boolean expression, because we are already aware about where which function is high, so we can easily write it. So let's try to write it. This is the truth table. Now write the Boolean expression for y, let's say y2. So the very first thing we are writing for y2. Okay, place it somewhere else. Okay, now so when we write about y2, how we will represent the y2? So y2, actually you are getting all these 4 places, it is high at all these 4 places. So once you consider this, it is 4, rest of the places are low. So this 4th place is high, so you can say either 4 or 5 or 6 or 7. So when these places are high, y2 will be high. So you can say either 4 or 5 or 6 or 7. This will give us high, right? Now if you write for y1, we will get high at these 4 places. So it is 2, 3 and then 6 7. So it is 2 or 3 or 6 or 7. Similarly, when you try to find out for y0, is high at 1 3 5 7. So it is 1 3 5 7. Now if we want to draw the circuit for this, let's say we are having different lines. So if there are 8 lines, and then we can write such kind of equation by having 4 input or gate. So if I draw it like this, so let me shift it. Okay, so let's say I am having it here, and rest of the things I am cleaning like this. Okay, now if there are 8 lines, input lines, so let me draw it quickly. So when we draw this circuit according to this truth table, y2 is having 4 5 6 7 as high, so we will connect. Let's say these are the input lines 0 1 2 3 4 5 6 7. We connect 4 5 6 7 in order to get the y. Similarly for y1 is having 2 3 6 7, so we can connect 2. 2 is this line, second number 2. Let's say it is connected 2 3. 3 is here, so 3. Then 6 is here, so 6. And then 7 is here, so 7. We can connect like this, and this will give us y1. Now similarly for y0 1 3 5 7, so 1 input is given here, so we can connect 1. Then 3, so 3 is here. Then 5, 5 is here. And then 7, so 7 is here, right? So this is the circuit for octal to binary encoder. I hope you have understood. So I'm closing this lecture. Thank you for connecting.